unconscious, automatically, and so on. And in lateral funiculus, we have sensory and motor. Motor red color and orange, and that sensory light blue. And in anterior, mainly by small exception, we have motor tracts. Here we have motor tracts, corticospinalis anterior. We have tectospinalis tract, we have vestibulospinalis, we have olivospinalis. You will mark and name this tract. But only name introduced with composition of white matter and nuclei of the gray matter. On this side, nuclei are located symmetrically here and here, pathways on both sides, but it is schematic picture, and all picture you must have name. It is on your picture 1 or fig 1. That fig 1. Name schematic representation of internal structure of gray and white matter of spinal cord. For example, when we will revise quickly, you can see nuclei, white matter, and their composition for oral test. And give short notes, please. Write nuclei, write data, up topography, anatomy and topography of the spinal cord. Because this term you will pass examine. This is internal structure. Do you remember meninges of the brain? What meninges? What spaces we have? Epidural, subarachnoid. And where is fluid? In subarachnoid space. The same, the cerebrospinal fluid flows in this space. And as you can see, arachnoid and duromater connected by fibers. Pyomater and arachnoid connected by means ligamentum denticulatum in thoracic region fixated pyomater, arachnoid to the duromater and to the intervertebral foramen. Duromater fixated to intervertebral foramen, this pink color. That is why all these meninges fixated with each other and to the vertebral column, and they fixate our spinal cord. It hangs in vertebral canal surrounding with water pillow, cerebrospinal fluid, and during walking, jumping, especially, and very high heels, goes when spinal cord every time has this vibration and this all structure connection between meninges. Help for fixation of the spinal cord in vertebral canal. They prevent from this shock. And after introduction with spinal cord external, all students will draw reflex arc, internal structure of the gray matter, internal structure of white matter, and also draw one segment. What does it mean, segment? We can conditionally spinal cord divide if we will have the forceps, scalpel, lancet. We can divide into these 41 parts, segment. It has metameric structure. One segment is called neurotome. It is one segment of the spinal cord. What definition we can give one segment? One segment is conditionally, yes, separating part, transverse part of the spinal cord, with symmetrically arising one pair of anterior root, one pair of posterior root, which gives rise to one pair of spinal nerve. This transverse part of gray matter, white matter, and one pair of spinal nerves is called one segment. How many segments we have? 7 cervical vertebrae, 31. But among them, we have 7 cervical vertebrae. But how many segments? 8. 8 segments, cervical, C1, C8, cervical, thoracic, 1, thoracic, 12, and lumbar, 1, lumbar 5, sacral 1, sacral 5, and 1 coccygeal segment. And segment length and length of the vertebra don't correspond to each other. Segments more shorter. Our spinal cord shorter. It ended on what part of the vertebral canal? Lumbar first, lumbar second, да? Picture of the vertebral canal we have that. No. It ended on lumbar first, second vertebra. That is why at first give you a picture of the spinal cord. This. At first, in cervical region, spinal nerves, number of the segment and vertebra corresponds to each other, and that is why spinal cervical nerves pass in upper cervical part horizontally. Starting from lower cervical, upper thoracic, one vertebra above located segments. They are shorter. They are located one vertebra above, and slightly oblique direction have this lower cervical, upper thoracic. In middle thoracic part, they have more oblique direction. They go 2 vertebra below to the corresponding middle thoracic. They go no further this 1, 2 below. On region of 12 thoracic and first lumbar, it is about lumbar. Where is lumbar? Lumbar 5th, 4th, 3rd, 2nd, 1st, and 12 thoracic. Da? About on this region, 11 are located all lumbar. Sacral and coccygeal, they are located 12 thoracic and 1st lumbar. So many, 5 segments, and coccygeal, they are ended on level of lumbar 1st or upper margin of lumbar 2. That is why puncture must be performed between interspinous and ligamentum flavum, this region, below of the 2nd vertebra, lumbar, da? Because the brain is absent, for prevents of damage of the brain, below than lumbar, for newborn, below than lumbar 3, you must perform. Thus, on the level of 2 vertebrae, so many segments are located. And their nerves must be passed, their sacral segments, here sacral foramina. They go no horizontal, they go how? Vertically. And leave about 5-6 vertebrae below, they pass and leave through the corresponding intervertebral foramina, sacral, anterior and posterior foramina. That is why in lower part, lumbar and sacral spinal nerves roots form what structure? Cauda equina. What spinal nerves? Lumbar and sacral spinal nerves. Lumbar and sacral spinal nerve roots form cauda equina. At first horizontally, then obliquely, and vertically. Number of segments and number of vertebrae don't correspond to each other. After introduction with structure, you will try answer questions for revision examination. Describe the appearance of spinal cord, its shape, its dimensions, the size, weight, dimensions, structure of spinal cord at its cross section. Then you will describe. So what is the segment? Give definition of segment. Designate nuclei. What nuclei of grave substance of the spinal cord? We can distinguish anterior horn, motor, posterior, sensory, interneuron, in lateral, sensory and autonomic. And then anterior, lateral, posterior, funiculus, cords of spinal medulla. What tracts pass here? Revise blood vessels and spinal medulla and meninges of the spinal cord and their spaces. After this, introduction with the brain. Only introduction, and from this text, please copyright to your notebook. From 1st to 12 pairs of the cranial nerves are site of arising. Here, for example, the cerebral peduncles. You will write about half page of the sheet. You will write these 12 pairs. First, olfactory, nervous find, and site of emerging, where it emerge on the brain base. For example, vagus, it lies in sulcus dorsolaterales medulla oblongata, where the hypoglossal between pyramis and oliva. You will find here hypoglossal between pyramid and olive, nervus hypoglossus, 11, 10 and 9 together they pass, 8. Copyright, site of, from general survey of the brain, you will read introducible brain, and very important, right, from 1st to 12th, name of the cranial nerves and site where they located, origin here. And the general survey here I will give. Our brain consists of 5 parts. The first part is telencephalon or end brain or cerebral hemispheria, which are covered by gray matter from outside and white matter inside, vice versa. No? In spinal cord, gray matter here, white matter from out. In end brain, do you remember neural tube has several layers, ependymal layer, middle mental layer, and external marginal layer. In the region of the anterior part of this neural tube, in this part, these middle layer cells migrate to external surface and form cerebral gray matter cortex. That is why in this region, next lecture I will deliver this, continue. Gray matter lies outside, but in white matter we can also find gray matter nuclei. In the cerebral cortex we also have inside the white matter we have gray matter nuclei, which are called basal ganglia, nuclei of reticular formation. Where is transverse section? Subcortical. This cortex gray matter is subcortical gray matter inside the white matter. This cerebral hemisphere. Under the hemisphere lies structure. No, hemisphere will describe next classes from all sides. Their dorsolateral surface or sulci, gyri, which are located here with their function. Their medial surface will describe their inferior surface. On inferior surface we have olfactory brain, olfactory bulb, olfactory tract, olfactory trigonum, substantia perforata anterior, 2 hemispheres separated by means fissura longitudinalis cerebri, connecting by means this corpus callosum, which has lamina terminalis, genio, truncus, and splenium of corporis callosi. Below of this structure lies fornix. Above we can see sulci and gyri of medial surface of hemisphere, this inferior surface of the hemisphere. Next classes will be all about hemisphere, the external, internal structure of the cortex, 6 layers of the cortex, function of the cerebral cortex, what fibers of the white matter inside, what nuclei will describe. After this, next part of the brain will be, in the cavity of the brain are ventricles, lateral ventricles, this hemisphere. Next part, what part you will study? This part is marked here, blue color. After hemisphere comes diencephalon. Diencephalon is this part, consists of hypothalamic region, thalamus, and the third ventricle. Next part after diencephalon comes mesencephalon. This is yellow, mesencephalon, diencephalon, mesencephalon, the third part of the brain, peduncles of the brain, and the structure on the base is called brain peduncles. From lateral and medial side, this structure is brain peduncle. This olfactory bulb, olfactory tract, trigonum, perforated substance, fissura longitudinalis cerebri, and behind we can see hypothalamic structure of diencephalon, optic chiasm, optic tract, tubercinereum, infundibulum, hypophysis, mammillary bodies, posterior perforating substance, and then comes mesencephalon region. This is pedunculus cerebri, these two peduncles with fossae interpeduncularis and substantia perforata posterior. From peduncles arise, turn your attention, the third and fourth pairs. Nucleus occlumatorius, this is third pair. Nucleus trochlearis, fourth pair. Dorsally from mesencephaly, dorsally represented by lamina quadrigemina, 4 collicles are located here. Lamina quadrigemina, and inside the cavity of mesencephalon is cerebral aqueduct, narrow structure which is called cerebral aqueduct. As you know, brain is developed from the vesicles, yes? And vesicles becomes thicker. Vesicle has cavity, primary brain vesicle cavity. When the walls become thicker and form hemisphere, this cavity becomes small. And remnant of this cavity of each is called ventricles of the brain. In hemisphere, we have two cavities which are called first and second ventricle. They are located in hemisphere. This is the third ventricle of diencephalon. This is the aqueduct which connects third ventricle with the fourth ventricle. This is cavity of the metencephalon. Metencephalon consists of pons and cerebellum. Pons and cerebellum, together with medulla oblongata, they are developed from posterior brain vesicle. Inside we have like tent-shaped this cavity, which is called fourth ventricle, third and fourth connected from cerebral aqueduct, aqueductus cerebri sivi. This fourth ventricle below connected with the central canal of the spinal cord, but also through the foramina connected with subarachnoid space. Fluid which flows in this ventricle cerebrospinal surrounds, through this foramina, surrounds the spinal cord. The central canal is mainly obliterated and fluid flows in subarachnoid space and outflow into the venous sinuses. Sinus sagittalis superior. This pons is called pons. Why it is called pons? Pons is bridge. In translation from Latin is bridge. Pathways which go from the cortex to the cerebellum. We have not direct pathway from cortex to cerebellum. At first they go to cortex to the pons, interrupted here, and then from pons through these transverse brachia pontis, they are called brachia pontis, like hands of the pons. Transmit, pass into the cerebellum, cortica pontine and pontocerebellar fibers. That is why this part of the brain is called pons, and it is connected with the cerebellum together form metencephalon. The fourth part of the brain, mesencephalon, metencephalon, and the fifth is medulla oblongata, or the cerebral bulb, because it like shape of onion or garlic, no? This cerebral bulb. Bulb, like bulb of garlic, for example, or onion. And decussatio pyramidum is the border with spinal cord. It has the similar structure with many common features of structure, medulla oblongata. That is why medulla oblongata has Greek name, mielencephalon. Encephalon is brain, myelon is spinal cord. It has brain and spinal cord common features. Yeah? That is why it is mielencephalon, very important part of the brain. This is both a mielencephalon continues with spinal cord. And all spaces, here dura mater cerebri continues with dura mater spinalis. Да. Они есть?
Мозги, позвоночник, конечно.
А где они вообще?
Препараты скрыть света.
Да, если можно. А можно сюда принести, что ли? Да.
Можно, только если староста даст свой студенческий и это самое.
Have you any reading card of your? Nobody has. Reading card your. Because library, да, или reading, читательский in Russian. Так, library card. Да, no student, library. Who has? No, Chish not give. For